So here we're going to start a lesson on polynomial modeling, and we're going to break it up into several smaller videos looking at specific types of polynomial modeling type of questions. So we start with these area type problems. Now our goal is to take a word problem scenario and create a function that will model that situation. So here, a gardener wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other 3 sides. So we have one wall that we don't need any fencing on, and then we're going to create a rectangular enclosure by making 3 sides. We have no idea how big these sides are, but I do know that it has to use 120 meters of fencing. So maybe that was 10 meters here and 10 meters on that side, and then this is 100. That would give me 120 meters of fencing, and we've made a rectangular enclosure. But what we really want to find is the dimensions that will give the greatest area. So here, these dimensions, if I found the area of that rectangle, would be 10 times 100, which is just 1,000 square meters. So if we change the dimensions a little bit, we can see how that would alter the area of the function. So say I made this 20, then this side would have to be 20, and we've now used 40 feet of fencing, so there's only 80 feet of fencing left. This time, if we multiply, we've got 20 times 80, and we get 1,600 square meters for the area. So the area has increased. What we're going to notice is that that area will increase and reach a maximum. So we want to figure out what is that greatest area. We're going to create a function that helps model this. So since this is some unknown length, we're going to let that be x. If that side is x, then this side is also x. But we saw that the third side did not have to be the exact same size. So I'm going to let that third side be y. What we do know is that it has to add up to 120 meters of fencing. So the perimeter of the fencing has to equal 120 meters. Well, if we add up the perimeter, that would be 2 x's plus 1 y is 120. We're going to use that equation to help create a second area equation, because the area of this rectangular enclosure would be length times width, or x times y in this case. So x times y gives me a function with 2 different variables. Hopefully you can't hear my dog deciding to chew and eat right now. But so we have x times y, and that would need to be 1 variable equation. So if I can create this into a 1 variable equation, like an equation of just x's, then we can use that to model the area. So I'm going to take this perimeter equation and solve for y. I would solve for y by subtracting 2x over here. So I have 120 minus 2x as that third side. Then if this was 120 minus 2x, the area is x times that. So we substitute that in and say area is x times 120 minus 2x. You could even distribute that x and get 120x minus 2x squared. But what we'll notice is that is a quadratic function. So since that is a quadratic with a maximum, it's got a negative x squared term, there would be a maximum point at the vertex. So we need to figure out what is the greatest area by finding the vertex. That vertex we have found of a quadratic using negative b over 2a for the x coordinate. And we're going to plug that in. In this case, b is 120 from bx. So we have negative 120 over 2a, and a is negative 2. If you wanted to rewrite this in standard form, you could write that negative 2x squared plus 120x. And then we simplify this fraction out. So negative 120 divided by negative 4 should be 30. That tells me the x value of the vertex. The output is actually a, so it's not y in this case, but a is equal to negative 2x squared plus 120x. And we're going to replace that x with the x coordinate that we just found, so 30. And we plug that straight into our calculator. So negative 2 times 30 squared plus 120 times 30 would provide an area of 1,800. What we found was the vertex of this area function. So the maximum area is going to be 1,800 square meters. So the actual question wants to know what are the dimensions and what is that greatest area. The maximum area is 1,800 square meters, but the dimensions are coming off of what x and y are. Now x is that x value that made the maximum area, so 30. So we would need 30 meters. And then we determine what y is. And there are a few ways that you could figure out what y is, but one of them is using that perimeter equation. Because we know that y is equal to 120 minus 2x. If I plug 30 in, 120 minus 2 times 30 would be 120 minus 60. And that's just 60 meters. So we have the dimensions of a 30 by 60 meter rectangular enclosure with a maximum area of 1,800 square meters. When we're solving polynomial modeling questions, I provided a few tips here, but you're typically going to need to draw a picture or something to help visualize what is going on in that scenario. Then we're going to create our maximum or minimization equation. This was our area function here, and we were finding the maximum area, but we needed to set up that equation with that perimeter information. And then we can use our maximization equation or minimization equation to find the max or min of that situation. So let's look at another one. In number 2, a rancher has 180 feet of fencing with which to enclose 4 adjacent rectangular corrals. What dimensions would be used to enclose the area that will be a maximum? So we still care about that maximum area. In this case, I don't know how big any of these sides are, so I'm going to let that vertical distance be x. That would mean that every vertical distance also has to be x. And I have this unknown horizontal distance as well. I'm going to let that be y. Now we just want to think about where are we putting the fencing. We're enclosing these 4 adjacent corrals, so every piece of this is being enclosed. That means I do need all 5 x's and 2 y's to make the figure. So if I put together 5 x's and 2 y's, I would use 180 feet of fencing. We want to know what dimensions would be used so that the enclosed area would be a maximum. So if I think about the area of this, the area would be x times y still, because it's still length times width. But I can't have a function with 2 different inputs here. So we're going to substitute in maybe one of them. It doesn't matter if you solved for x or y to substitute. So I look at this equation and just decide, do I want to solve for x or do I want to solve for y? I typically solve for y, but it does not make a difference. So if I subtracted 5x and then divide by 2, we get y by itself, and it's 90 minus 2.5x. That means when we see a y, we can replace it with 90 minus 2.5x. That gave me a new equation for the area that is only a function of x, so the only input is x. If I distribute, we get 90x minus 2.5x squared. And then we would want to find the maximum area, just like we did in the last one. So this is a quadratic function that has a maximum because it has a negative x squared term. To find the maximum, we need to find the vertex. So let's look for where that vertex is located. We start out with x equals negative b over 2a. That gives me the x coordinate of the vertex. So negative 90 over 2 times negative 2.5. And we can plug that into our calculator. Negative 90 divided by 2 times negative 2.5 should give me 18. The area associated with that would be 90x, so 90 times 18, minus 2.5 times 18 squared. We plug that in. 90 times 18 minus 2.5 times 18 squared is 810. Now let's think about what information do we actually need. We want to find the dimensions that would enclose the maximum area. So let's look at those dimensions. The dimensions that make the biggest area, x by y, would have an x distance of 18. So 18 feet. And then we need to know, what is the y distance? Now y is equal to 90 minus 2.5x. So if I use that relationship, 90 minus 2.5 times 18 would be 45. So the best dimensions for this would be 18 feet by 45 feet. Then it asked a second question. So the second question said, what will the area of each corral be? And I threw this one in here just to make sure that we understand what the difference is. So the maximum area of the whole thing, the way that we set it up, was x times y. That maximum area was 810 square feet. So each one would be 810 divided by the 4 corrals that we created. So we have to figure out, what is 810 divided by 4? So 202.5 square feet. And there we have our maximum area of 810 square feet. If I divide that individually, each corral would be 202.5 square feet. So there are some area problems. We're going to move on into another video about volume.